Going on now to topic 6 of chapter 6, division of polynomials. We're going to show you the method for dividing by a monomial and then later by a binomial. See, we left the teaching notes there. Okay. Now, the technique for doing this is rather straightforward, and this is how you should set up the example each time. Now, I'll write it out here. So it's 60 x to the fourth plus 72x. Now it's dividing it by 12. So what we do is we put that monomial under each of the terms in the numerator. And now we just simplify. 12 goes into 60 5 times. 12 goes into 72 6 times. And that's as easy as it is. Now in this next one, it's, again, you write out the terms. And the denominator is placed under each of your terms in the numerator. And now you just simplify. So 5 will go into 20 4 times. The 3 comes up, you subtract it from 5, you get a to the second. Now we have to respect our sign. This will be a negative. 5 goes into 35 7 times. A to the third from a to the fourth, you get a 1 that we don't write. And 5 goes into 55 11 times, and these just cancel out. And there's your answer. So the key is place what is in the denominator under each of the terms and just simplify. Now, if, for instance, instead of this being a 3, this was a 4, then, this would become a 1. This would cancel out completely. And here, you would actually have a letter in the denominator. Okay? But that's not how it is. We're just giving you a for instance. Now, when we do division in which there is a binomial in the denominator, we have to use a method called long division. And you set it up like so. N plus 1 divided into n squared plus 8n plus 7. Now a little background on this would be if I were to divide, let's say 5 into 2, 6, just make it simple, 26. We would say that how many times does 5 go into that? Well, we say 5 times. We then go 5 times 5 is 25. Now, what do I do here? I subtract. And in algebra, to show subtraction, we change the sign and then we add. So we get a difference of 1. So this would be 5 goes into 26 5 times, and there's a remainder of 1/5. We take our remainder and put it over our divisor. Okay, so that's what we're going to do here. N goes into n squared how many times? Well, n. And if you're wondering, a technique for that would be put the n squared divided by n, and what is that? Well, that's n. That's what we put here, because now n times n will give you n squared. N times n gives you n squared. Then we take our other term, positive 1 times n, gives you a positive 1n. Now we don't usually write the 1, but for clarification we can. Now, what did I do here? Well, I got a 25, but to indicate subtraction, I had to change the sign. So I'm going to subtract this by changing the sign, changing the sign. So now this cancels out, becomes a 0. This becomes a 7n plus n. And if I take my 7n and divide it by n, it goes 7 times. So n times 7 is 7n. 1 times 7 is 7. Now, what do? I change my signs, and this cancels out, and this cancels out. Now, a check of this would be to FOIL this by that, and it gives you this. All right, let's try another. Now, here we have x squared, but there is no x term. So what I have to do is to put in a space holder that has no value, but gives me a place to work it in doing long division. And I just set it up similarly to what I did before. X minus 4. Now, x goes into x squared. You can just divide it. It's x times. X times x is x squared. Now, a negative 4 times x is a negative 4x. Notice I have a place to put it as I go through the sequence of this. Now, what do? Well, I change my signs. This becomes negative, and this becomes positive. This cancels out, and I end up with a plus 4x. I bring down my 15. And x goes into 4x how many times? Plus 4. So I get x times 4 is 4x. 4 times 4 is a negative 16. And what do? I change my signs and I add. This cancels out, and this becomes a positive 31. So my answer will be this plus 31 over x minus 4. That is my remainder. All right, let's pause. And that checked out. Let's go on to letter C. We'll set it up over here. So 2y squared plus 1 divided into, any missing places? No. 2y to the third plus 8y y squared plus 3y minus 1. It's surprising how many errors are introduced when you don't copy the problem correctly. Now again, if you're wondering how many times does this go into that, use this technique. 2y cubed divided by 2y squared. And this just goes into there y times. Now, we're going to go 2y squared times y gives you 2y cubed. Now, a plus 1 times y, you have to put this in its right place. This is a 1y. Now, notice what happens here. We're going to draw our line to subtract, change the signs, and this then becomes 8y squared. This is going to become a plus 2y, and you bring down the minus 1. Now we have 8y squared divided by 2y squared, and this is going to go 4 times. So we go 2y squared times 4 is 8y squared. 1 times 4 is 4, plus 4. Put our line, change our signs. This cancels out, and we are left with 2y minus 5 as our remainder, all over 2y squared plus 1. And that is our answer. Again, they don't all come out so nicely as we did here, but you must follow the protocol and item by item. Again, a lot of algebra and a chance for an error, but be careful as you do it. Okay, let's go on here. Now our last one is a function where we're going to divide this by this, and that's what they show here. This divided by this. So this is what we have over here, 4t minus 3 divides into, now lots of missing places here. There's 64t cubed. There is no 0t squared. There is no 0t. We're putting in place holders or space holders. And then we have a negative 27. Now, I don't know if you've noticed this, but this is the difference of perfect cubes. And I think might be a good time to review this. What are the factors of this? Well, the factors of this, we said we need a parenthesis for 2, a parenthesis for 3. We take the cube root of this, and that gives us 4t. And we use that sign is negative, by the way. And the cube root of this is 3. And then it was opposite side over here. Square this. That's going to be 16t squared. Multiply this together. That was a 12t. And then square this. This is a plus 9. And I expect that's what we're going to get up here. So we're dividing this into that. So if we multiplied this by that, we got this, which is what's there. So let's do the division of it anyway. So 4t goes into there 16t squared times. 4t times 16t squared is 64t cubed. 3 times this is a negative 48t squared. Okay, we're going to put our line, and now we have to change signs. This becomes a negative, this becomes a positive, so we bring down our 48t squared and a plus 0t. Now 4t goes into there 12 times. 12t times. 4t times 12t is 48t squared, and 3 times this now is a negative 36. Put our line, change signs. This becomes a negative, this becomes a positive, and we get 36. There was a t there. T, bring down our 27. Now, 4t goes into there, 12. 4 times 9, to 9 times. 4t times 9 is 36t. 3 times 9 is a negative 27. Put our line, change our signs, and it all cancels out. And let's see if we got the same thing. Yes, there it is. So notice that in the recipe we say whatever this sign here goes there, opposite sign. Notice we have that opposite sign there. So it's just part of that recipe. Now they do ask us for one other thing. What are the restrictions of the domain? Well, in doing our domain here, this is what our domain, well, our denominator would have been. We're dividing this by this. So we equate the denominator to 0. This becomes a 3. Divide by 4. And we say t cannot be a 3/4. T could be any number, but it cannot be a 3/4 because it would make this denominator a 0. That's the restriction of the domain. All right, let's go on and take a quick look at the answers. And that is correct. Okay, we'll be going on to topic 8 now, in which we do formulas, applications, and variations. That's coming up.